Alright, before we've seen how to solve uh, equations with just one variable. We've seen solving inequalities, absolute values, all with one variable. Now we're introducing solving equations with two variables. And to do that, we need two equations. So for this chapter, we're going to be solving systems of equations. Systems of equations are basically a problem with at least more than one equation involved. So here we have two equations, y equals negative 3x plus 4 and y equals 3x minus 2. And we want to find an x and a y that satisfy both of those equations. And the first method we're going to show you today is solving by graphing. And by this method, we're just going to graph both of those linear equations on the same coordinate plane, and the point of intersection is our solution. So let's start by graphing. So y equals negative 3x plus 4. That's slope-intercept form. So we're going to go to plus 4. That's where we start. Use our slope. Down 3 over 1. Down 3 over 1. I'm just going to draw or sketch my line. And then 3x minus 2. So we're going to start at minus 2. Go up 3. 1, 2, 3 over 1. 1, 2, 3 over 1. Okay. Now both lines have been plotted. Now our point of intersection is our answer. So our point of intersection is right here. And that's 1, 1. So our answer is x equals 1, y equals 1. Oops. Okay, so now we can just check to make sure. So I'm just going to plug into the first equation. We have 1 equals negative 3 times 1 plus 4. And I'm going to plug into the second equation just to make sure. We have 1 equals 3 times 1 minus 2. 1 equals 1. So they both check out. So our answer is x equals 1 and y equals 1. When you're solving by graphing, you're going to see three types of answers. You're going to see one solution, infinite solution, and no solution. One solution answers with linear problems when you graph the two lines and they have one point of intersection. So that would be one solution. Now these are just for linear equations. Then we'll have infinite solutions. That's if we plot both of the lines and they turn out to be the same exact line. So after plotting both lines, they're pretty much right on top of each other. That means no matter what x and y we pick, it's going to satisfy the system. And then we have a third option, which is no solution. So if we plot our lines and they're parallel to each other, it means they never intersect. So that means they would have no points of intersection. So that means you would have no values that would satisfy both equations. So if they're parallel, it's no solution. If they're the same line, it's infinite solutions. And if they intersect at one point, it's one solution. Okay, after watching this video, you should be able to do these problems. For these, you're going to solve these systems by graphing. Keep in mind that for this guy over here, you're going to need to write in slope-intercept form first. So you get y by itself, solve for y, and then you can plot it. And when they're talking about consistent, independent, consistent, dependent, inconsistent, they're just asking for one solution, no solution, or infinite solutions. Okay? So just tell me how many solutions it would have and what the solution would be, and then you'll be good to go.